Welcome to a lesson with Dr. Powell. Let's take a look at how we can use Descartes' rule of signs and the upper and lower bound theorems and the rational roots theorem to narrow down a list of potential zeros or x-intercepts of this function to a more manageable one that we can check. Okay, so first of all, the rational roots theorem basically says that we're going to be looking at a list of potentials that are factors of this guy, the constant, divided by factors of 1. So essentially, it just says that we're going to be looking, our list of potentials is just the list of factors of 24, positive or negative. So this is our list that we're going to be narrowing down. Right now, there's too many things to check. So let's narrow some things down. First, let's look at Descartes' rule of signs. Descartes' rule of signs says the number of positive x-intercepts, it can be, at least what to expect, can be seen from considering the sign changes as we read from left to right in the coefficients. So we read positive, negative, positive, positive, negative. So reading from left to right, we notice one sign change, another sign change, no sign change, a third sign change. Okay, so there's 3. So that means the number of positive x-intercepts is either 3 or 1. Remember how we go down by an even number. So 3 or 1 positives. So that means we definitely want to leave our positive list for now. So then we go to our negative list. If we ever get that there's only 0, then we can eliminate 1/2 the list. Sometimes we can't quite get that. As in this case, we'll see. So, for instance, let's see. We need to reflect this across the y-axis. So what's negative over here becomes positive. Then we can apply the same test. To do that, we plug in a negative x everywhere. So negative x to the 4th minus 5 negative x cubed, putting a slot in for the negative x to go. Okay, and even power, we'll just leave this as x to the 4th. An odd power will allow this negative to come out, interact with that negative, become a positive. Over here, that'll just be a positive. Over here, we'll have a negative 20x minus 24. Notice that as we read from left to right, there's only one sign change. So we know for sure there's 1 negative. Okay, we got to keep both parts of the list. That didn't really help us narrow it down. But maybe as we go, if we don't find 1 negative, then we know not to search for any more negatives, but go straight to the positives. So that could be helpful. But anyways, Descartes' rule of signs can be handy. It can help us know when to stop doing something and when to go to another part. Okay, so that was kind of an initial survey using Descartes' rule of signs. All right, next, let's use the upper and lower bound theorem to kind of help us a little bit more. Now, how does this work? This actually works as we begin to try things out. Okay, well, why don't we try out, I'm just going to stick 4. I'm going to do something kind of in the middle of the list. I'll just do 4. So let's do 4, positive 4, just stick it in and see what happens as we go. All right. So we have 1, let's see, 4. Let's see, we get a negative 1, we get a negative 4. Okay, and we get a negative 2, we get a negative 8, we get a 12, I get a 48. Oh, it looks like we didn't get anything, okay? And the signs are kind of going back and forth a little bit. So maybe we're still in business. Why don't we go just a little bit higher, okay? Let's go a little bit higher now. Let's go up to, instead of doing 4, why don't we try 6? Okay, so it's just kind of sticking around there. Let's do 6. Let's see what happens. We get a 1, 6, we get a positive 1, we get 6, we get 8. You get 40. It looks like all the signs are tending to be positive and look like they're going to stay positive, right? 36, so 4. Yeah, so 6 times 8 is 48. So 408, I believe. Okay. So, and that's definitely positive right there with 300. Let's see, is that 384 or 80? Sorry, not 384. Yeah, 384. Okay. So it looks like it's all positives. Well, that tells us something automatically. That means 6 is too big. We already just checked 4. So then we know we can rule out these 3. Look how we just ruled out those 3 right away. But we know that we're going to have some positives, and we're going to have to find the positives in here. So we only have 3 things right there to try. Let's see if we can reduce things on the negative list now. Okay. All right, so let's see if we can look at the negatives, so plug something else in and reduce that list. Okay. All right. So, why don't we try, let's see, and we could try -4. I don't know. Let's just try it. See, 1, -4. So that's -9. That's 36. Yeah, 36. That's 38. That's negative 120 and 32. So yeah, it looks like yeah, it looks like we have so -32, so -152. It looks like we're getting some big numbers here. We have a positive, negative, positive. So let's just write this up: positive, negative, positive. It looks like we'll have a negative, and this will be a big positive, and then we'll have another big positive here. Looks like a nice alternating pattern already. Well, once you hit an alternating pattern, you know that this is out, and anything below it is out too. So really, we've just reduced ourselves to checking just 6 things, just 6. Okay, so so in the next video, we'll actually go through the process of checking those. In this video, what did we do? We used the rational roots theorem to write out our list. Then after we wrote out our list, we used Descartes' rule of signs to kind of see what we'll be looking for, just kind of we can know here we only have 1 negative. So once we find 1 negative, just move to the positives. Here for positives, we know we have 1 or 3. Now, and then we use the upper bound and lower bound theorem to eliminate a lot of our lists. So we only have 6 things now to try. Thanks for watching.